On the energy side, we recognize four types of energy now. Gravitational energy, electromagnetic energy, the weak nuclear force, and the strong nuclear force. So if you wanted to imagine four types of wind, if you wanted to make your analogy better, you might want to do that. But if you just want to collapse all those 24 particles and say, let's just let one type of sand particle represent the 24, and let's let one type of geophysical force, wind, represent the four basic forces of the universe. You know, we could accept that as a simpler analogy. I'd be willing to go along with it. So the question then is, if we do this analogy in the way I've described, how would the analogy work itself out? Well, the way it would work itself out is, yes, after a sufficient amount of time, the wind, representing the four forces of the universe, would move around the sand, representing 24 different types of subatomic particles, to produce complex objects over the course of 13.7 billion years. Yeah, that's the way your analogy would correspond to what's actually happened in our universe.
So first of all, I'm glad that you acknowledge that we can come up with a workable analogy, and actually the workable analogy can explain what, you know, simplify what happened in the universe. And I really, you know, appreciate this acknowledgement, and I think that's exactly what I try to do, because to me that it's really to simplify something through analogy can better help us to understand the complexity of the event. That's why I personally try to use analogy, or try to simplify the event to understand really what's going on there. And that's, you know, I think you're helping me to come up with a workable analogy. I appreciate that. I think that's good. Now, the problem I have with that, now once you accept this analogy as a workable analogy to just simply understand what has happened in the universe, now when I look at it, I say, you know, okay, what after the Big Bang, and actually scientists will tell you that not, you know, long time after the explosion, it was very short time, perhaps a matter of minutes, that we start to see the combination, the arrangement of those basic particles in a form of subatomic particles. And perhaps we start to even observe very simple, you know, atoms, just very short time after the explosion. Now, question I have that when I really studied all and look at it, I'm not expert in, I'm not physicist, you know, expert in physics, but what I understand from their work, to me that it is fair and accurate to say that the structure as an atom, or even the structure as a subatomic particles, like perhaps quark, like, you know, neutron, are, if you truly study them, are more complex than any man-made structure that you know. Indeed, I made this argument before. I'll still, you know, I will be willing to challenge to say that if you can prove that the structure under subatomic world is less complex than the most complex man-made object, I will give up my debate. Now, if any single atom is more complex than the most complex man-made object, I will say, since everything now we observe are made of atom, that means that everything without exception are more complex than man-made object.
Well, your idea that a single atom, for example, let's take a hydrogen atom, hydrogen being the simplest element, the simplest atom that we know to exist, is more complex than any man-made object. It just seems bizarre, ridiculous, and irrational. And the burden of proof is not on me, it's on you. Because, based upon our current knowledge, we know that the hydrogen atom has just a few parts. That is, it's one proton surrounded by one electron, if my memory serves me correct. And the proton is constituted by 3 quarks. So, from what we can tell so far, the electron, the hydrogen atom has 4 parts. Now, as I understand, there may be what's called these connecting particles that go between the nucleus and the electron. So we might add a few more parts in there. But let's just say the hydrogen atom, as far as we know, may have 10 parts. Okay. That's a very low level of complexity compared to the hadron accelerator, Large Hadron Accelerator over in France and Switzerland. So to claim that the hydrogen atom is more complex than the most complex man-made object seems bizarre to me. Yeah, I don't accept that. I think that's a false conclusion. And the burden of proof would be on you. You would have to demonstrate. First, you'd have to define what you mean by complexity. The common definition of complexity has to do with number of parts. Surely, that's one of the parts of the definition. So, just going on that, your conclusion does not hold any water. So we can get more into that, but that's enough for now.
Okay, I think I think I can make such an argument and say that any single atom is more complex than any man-made object. I think that's really is not something that even that we should debate it. It's something that we should go and ask an expert and say, okay, if you are an expert in physics, let's do that. Since we are discussing here, maybe some of our audience are actually expert in this area. They can help us, or we can reach out some expert in physics and ask them and say, can you tell us that whether we will define complexity? Here's my definition. We will ask them and say whether we can make a claim and say any atom is more complex than any most complex man-made object. That's the question we're going to ask. We will share with our audiences. I think that's something feasible. We don't need to debate and waste time on that one. But here's the definition of complexity. I agree we need to define complexity. My definition of complexity is not the number of particles. It is the number of steps that you have to take in order to make an arrangement. Because everything, after all, is just the arrangement of those basic particles. Now, when we talk about man-made complexity, it means that man-made gets certain object and actually add layer of complexity by making a certain arrangement of these objects. So the arrangement will go through certain steps. They will start to do A, B, C, D, and each step will connect to each other, and ultimately they will get the high level of complexity. So to me, in this case, yes, some steps might be more difficult than the other step, but ultimately there are certain steps that you need to follow in order to make a certain arrangement and reach the certain level of complexity. My argument is that if you were going to build an atom from scratch, you have only the basic elements which you think came out of the Big Bang. Now, for you, in order to understand the complexity of an hydrogen, you need to define every single steps need to be taken from the explosion to the level of building the hydrogen. So if you define that, and if you do experiment that you can actually show that works, that can give you hydrogen, then I will say yeah. But you can't just go and actually get some, ready component and then say, you know what, look at the car. It's not that complex. After all, it's just 4 tires and a wheel. See, if you have a tire, it runs. Yes, the tires are the basic component of the car, but that doesn't mean that the car is just made of tires. So the same thing that what you observe in those elements is that might be more complex than beyond your observation.
Okay, well.